G'day, so we're looking at integrating with problems today. So the question that we have up here, we're going to go through three different questions and three different examples. Each of them are going to be a little bit different to each. So you can see that one we're looking for the language that we're pulling out of the equation to help us solve. And also the type of equations you're looking for to see what kind of calculations you have to follow. So let's get into this first one. We've got the rate of traffic flow at an intersection is given by dn dt is equal to 500 e to the power of negative 0.75 t, where time is between 0 and 4 hours. Okay? Or minutes, sorry, 4 minutes. The number of cars that pass through the intersection in the first 3 minutes, or 3 hours, so these are hours, is approximately 658 cars. So, we want to use rules of integration to find the number of cars passing through the intersection between t is equal to 0 and t equals k. Well, what we know so far is that if we have dn dt is equal to 500 e to 0.75 t, what it's asking us to find is the number of cars. So in terms of number of cars, we're integrating this to get nt in the presence of 0 for t to k for t. So let's have a look at that. So let's integrate this. We know that when we integrate 500 e to 0.75 t dt, we get 1 over 0.75 times 500 e 0.75 t from k to 0. Now, if we have that in this instance, one thing that I'd like to do is to try and simplify this up, because leaving it in this form is going to make it a little bit complicated later on when we start doing calculations. So let's simplify this, and we get, let's get the calculator out. 1 over 0.75 times 500, we get 2,000 over 3 e to the power of 0.75 t. And we're going to be doing that from k to 0. So now that we have a more simplified version, we can now substitute our k and 0 in to get our values. So we will get 2,000 over 3 e to the power of 0.75 k minus 2,000 over 3 e to 0.750. Well, what do we get when we look at this? Well, we end up getting 2,000 over 3 e to 0.75 k minus 2,000 over 3. Because we're going to times this by 1, we just get 1. We now have a function in terms of number of cars. But what we want to do is we want to be able to maybe simplify this up, because my next question here is, hence, estimate the nearest minute when the thousandth car passes through an intersection. Well, I could use this, but it's going to be a little bit problematic. So what we can do, if we have an opportunity, is let's simplify it. So if we simplify it, what we notice straight away is that we've got a common factor of 2,000 over 3. So we can rewrite this here as 2,000 over 3 brackets e to the power of 0.75 k minus 1. And this here is a better function to use for when I go into this second question. So where we know that where k is equal to t in this terms, because we've got in time. So we've done that first question. We've used integration methods to be able to find the integral of difference in number of cars over difference of time. Alrighty, so let's look at the second part of the question. So the second part of the question uses I'll leave it as K. We'll leave it as K for now. Uses this formula that we just found out. So it says, hence, estimate to the nearest minute when the 1000th car passes through the intersection. Well, this is a number of cars, so we can say that 1000 is equal to 2000 over 3 e to the 0.75 k minus 1. We've got the formula up here. Let's rearrange it so we can get what k, or where t is, in terms of time. So the first thing is, let's multiply by 3, which gives me 3000. If I divide by 2000, I get 3 over 2. So it's 3 over 2 is now equal to e 0.75k minus 1. Let's get that 1 over to the other side, so we get 5 halves is now equal to e 0.75k. And now we're at a point where we just want to use our natural log. So our natural log will tell us that if we take the natural log of this side, we naturally have to do it on the other side. So we get ln 5 over 2 is equal to, these two cancel out, 0.75k. So we're nearly at the end that we're looking for. We want to find k by itself. So therefore, k is now equal to 1 over 0.75 times ln 5 over 2. So that's my exact answer. My exact answer is not what I'm looking for here. Where k, we're right here where k is really equal to t, because we're trying to find time. It's asking us to find estimate to the nearest minute. So if we put this into our calculator, let's see what we get. So we'll get 1 over 0.75 times ln 5 on 2. We get approximately 1.22. Now this here is 1 hour and 22 minutes. So we need to work out, well, what is 22 minutes of 60? So therefore, 0.22 times 60 gives me, let's see, 0.22 times 60 is approximately 13.2 minutes. So therefore, we have 1 hour, which is 60 minutes, plus 13 minutes, gives us approximately 73 minutes. So it's going to take approximately 73 minutes for the 1000th car to come through that intersection. How do I know that I'm correct? What can I check that I've already have a calculation for that tells me I'm on the right track? I have it here. It says in that first 3 hours, okay, the first 3 hours, 5,658 cars have actually passed through. So therefore, we would expect that for 1,000 cars, that number that we get should be less. So 3 times 60 is 180. So we are getting something less, 73 minutes. So we know that we are on that right track. So that's our first video on problem solving. I'll see you for the next one.